Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again into this TV learning program. My name is teacher Jean-Marie, and today lesson is with the Senior 4 students. Senior 4 students, I hope you are ready to study physics with me and to continue Unit 4 that we are discussing. And I hope you remember the last lesson that we were discussing. It was about the collision into two dimensions. And now let's have another related lesson, but it is about solving problems two-dimensional collision. So this is what we have today. And at the end of this lesson, I want you to be able to describe elastic collisions of two objects with the different masses, with the different mass. We have a mass 1 and a mass 2. The last time we could discuss with the same mass, but again, we are going to do the problem that we left the last lesson, and we do it just right now. A few minutes, a few seconds, I'm going now to solve it, and you compare the answers with what you have determined, okay? And another objective number 2 is to solve problems related with the two-dimension collision. So I hope with the problem that we are even going to solve, so it is an example of problem that we'll be solving into two-dimension collision. And we add on more other examples, okay? So then, students, let's have a continuation. So here we have, on the previous lesson, consider the diagram below to calculate the speed of white ball if they have the same masses. So here is the diagram. I've tried now to draw, to reproduce the diagram on the board here. So this is the white ball. So let's say that we have this mass of the white, and here this is the speed. This is u of the white equals to 4. But the black one here, it has u of the black is 0. You know, to be 0 means that it's at rest. So here it is at rest. This is at rest, and the mass of this one is black. So of course it is equal to the one of the white. And this is where the black was taking the direction. It is taking this direction at an angle of 45 from the original direction from what was the collision before. Before the collision, we have this direction, and when we compare the direction taken by this black ball, so we see it at 45 degrees. And the white one, it is below the line at an angle of theta. And here is the white. Now, to correct this question, here we have a correction. And you know, we use the conservation from the conservation law of momentum. You know, here we say before and after. So we know that we have mass. This is M1, U1 plus M2, U2. This is equal to M1. But remember what we have said the last time. We say we have a component of this velocity, but along the x-axis, and this is v cosine theta, and this is theta 1, and here we have mass 2, then v2 cosine theta 2. But you see, I'm using 1, 2 into this formula. And what we have from the problem here, so we can compare with this equation, and then we find that we have the mass of the white, then hue of the white, plus mass of the black, hue of the black, which is equal to mass of the white, then speed of the white bar, cosine of the angle taken by this white, which then plus mass of the black, V of that black, the final velocity of the black. Then here we have cosine theta, theta of the black taken by, this is the angle whereby we see the direction of the black. This is the white, and here we have the black bar. So, and as what you see, we can substitute. So if we substitute the data, here we have the data here, we substitute, but since the bar have the same mass, the same masses, then what we have here is that M white equals to the mass of the black. And on both sides, you see we have the mass. We can simplify, or we can cross them out, and we remain with just with only the velocities. Now here we have the substitution. If we substitute, we find this is 4, which is equal to then 4 plus 0. 0 because here we have this is the mass, the speed of the black bar, and it is 0 because we have said that is at least. So remember what we have said. We say that these are closed out because they are all equal, and they are on both sides. And what we have here equals to, this is the speed of the white. The speed of the white is down here, and this is where we have the speed of the white. Cosine theta, so that is theta of the white. Then plus the one of the black. Here it is V of that one is equal to 2 cosine 45. Here we have 45 degrees. And when we solve, we find V of the white cosine theta white equals to, this is equal to 4 minus 2 square root 2 over 2. You know here cosine 45 is cosine 2, cosine is square root 2 over 2. Cosine 45 equals to square root 2 over 2. And with this 2 here times that square root 2 over 2, and then we find this 4 minus square root 2. This is V white cosine of the white ball. Remember, the white one is down there, okay? So this is the equation 1. So let's say the equation 1. And again, when we proceed to another equation, so we have this one here. So along, this was a discussion along the, so this was along the x-axis. So this is what we have. And then let's have along the y-axis. What do we have there? So what we are going to determine is going to be, so look, here we have M1 U1 plus M2 U2. This here means that we have the velocities along the x-axis. That is before collision. But along the y-axis, we don't have this velocity. To say that we don't have this velocity means what? Means that the velocity before collision is 0. And then the momentum before collision is going to be also 0. And this is equal to 0, which is equal to, that is the mass of the, as what we did here. So down there, the mass of the white, V of the white cosine. No, this is sine of theta white plus mass, and this is the speed then sine A of the black. This is what we have, okay? So then students, when we also, because we have the same mass, so these are closed out. Here we have, we remain, after the substitution we find that is 0 equals to, here we have speed of the white is the one that we are going now to determine. And this is the V of the white sine theta white plus what we have here, the one of black, is this. And the speed, the final speed is 2. We have a 2. Then sine 45. That is the angle that we have from this direction, as we are saying. And we can find that V of the white sine that theta equals to minus 2 square root 2 over 2. You see that? And then we end up with the speed of that white theta equals to minus square root 2. And this is the equation 2. If from, just by dividing both equations, from 2, this is 2 over 1. So what I'm saying, if we divide the equation 2 to 1, what do we find? So this is, I think it is what we have tried out to do the last, but it is what you have proceeded to find the equation. So here it is, this is V. On both sides we have a V omega. No, this is of the white sine theta of the white equals to over V of the white cosine theta white. This equals to minus square root 2, then over 4 minus square root 2. You know, this is what we have here. And then, according to what you see, we have the same, we close out this V, and we remain with the tan theta of that white equals to minus square root 2, 4 minus square root 2. And what do you think is going now to be theta? Theta will be equal to inverse of this tan. Then you have that is minus square root 2 over 4 minus square root 2. So, and what you find here is that angle. Students, can you use the calculator and then find that? Okay, so here's what we have. So as what is here is that a tan. So that is the inverse of tan, and then we have square root. That is minus square root 2, and then we divide. So let's use the parentheses, you know, now to avoid some errors. Here we have 4 minus square root of 2. And what do we find? We find that is minus 20. This is minus 28.67 degrees. And of course, it is approximately 29 degrees. This is the angle, okay? So I hope that is what you have determined, yes? And now let's use this angle. From this angle, we can find, V of the white. And so let's use this equation. So we can use this, or we can use this one, but if we use this one, means that we have V of the white bar equals to minus square root 2 over sine theta of the white, and this equals to minus square root 2 over sine minus 29 degrees. And what is going out to be this speed? And again, you have that. And then when you have this is going to be, so here we have minus, this is minus square root 2, and then we divide by sine, this is sine 29, minus 29, and this equals to, and this is, so then here we find, so what do we find? No, so this is minus, this is minus square root 2, then over sine, this is sine minus 29, and so, can you calculate that? So what do you find? So this is minus, that is negative square root 2, and then I use some bracket, and this is sine negative 29. Okay, students, if we use a calculator and then we substitute what we have there is going out to be minus a. This is minus, let's use the parentheses, okay? We have a minus square root 2, and we close it then over. That is sine, then negative 29. And what we find is 2, that is 2.9, 29 meter per second. Remember, it is the speed, okay? So this is the speed that we are determining. Then we have the answer, and this is the speed of the white. So if we go back here, we can find that V equals to 29, that is 2.9 meter per second. And I hope this is the correction of that. So then you can proceed to the elastic two-dimensionals. What we have there, you see that is a diagram from the last presentation. So, but here we have the masses. So these are the masses that we have, okay? So this is a mass and another mass. But they are also having the speeds. So this one is moving and another also is moving, which means that we have the conservation of momentum before collision. In this conservation law, we have the term that expresses the momentum of the second ball. And then we have this is during and then after. So then students, if you remember, from this diagram, we can derive some equations. Which ones? So you know the conservation of momentum now is given along the different axes, okay? So then let's start here by along the x-axis. What do we have? So this is before here we have, this is M1, U1, let's say that is x, okay? Plus M1, then U1, this is M2, U2 along the x-axis equals to M1, then V1 cosine theta 1 plus M2 V2 cosine theta 2. The conservation law of momentum, but along the x-axis. Then along the y-axis, along the y-axis, what do we have? We have this is M1, then U1y plus M2 U2y equals to what? This is equal to M1 V1, and then a component along the y-axis, that is sine theta 1 plus M2 V2 sine theta 2. So if we have this, if we remember from what we did the last time, if we have this component, then it is okay. But if we don't have it, that is going to be 0. You understand? So then here, we are not going to consider it. Remember, this is before collision, okay? So let's have a quick example, and you could now understand this. You could understand what we are saying from this problem, okay? So then, students, we have the problem one here, and this is the cars. So we have a car of a kilogram. This is a 1,000 kilogram. Is moving eastward at a speed of 20 meters a second. It collides inelastically with another one of 1,500 kilogram. Van traveling northward at 30 meters a second. What is the velocity of the two vehicles immediately after the collision? Now, this time, when colliding, they will now they will stick together and they move with the same velocity. So let's do this question. This is a correction here. What do we have there? So we use this equation here and that one. So first of all, along the x-axis, what do we have? So we have that car, that small one, the one of 1,000. What we are going now to use is here, okay? So look, the mass M1 will have it. This is 1,000 kilogram, then times the speed along the x-axis. The speed is 20. That is 20. Then here plus, do we have the speed of the second car along the x-axis? No. What we have is the speed of this second car along the y-axis, which means that it is plus 0. 0 means there is no component of the second car along the x-axis. Do you understand? So then this is going out to be equal to what? This is equal to they will now be moving with the same velocity and at the same angle also. Okay, so with the same velocity means what? Here we have the mass 1, okay, and the mass 2. They will all be equal. So already substitute, we have this is 1,000, then times v, and this is sine theta plus the mass of the second car is, this is 1, 5, then we have sine theta. And what about along the y-axis? The y-axis. So along the y-axis, we have this equation here. So we don't have that, but we have this, which means that we have 1, 5 times the speed. The speed of the second car is 30. This is 30. And this is equal to what we have there. That is the component. That is 1,000 times the v. No. Here it was along the x-axis. Then here we remove this sign. Sorry. So this is going out to be cosine. So let's have here sine theta plus 1,000 v sine theta. So this is cosine here, and there we have a cosine, okay? So when we solve these two equations, here's what we are going now to find. This is going to be, what do we have there? So we have this as the, this is 2, 0, 0, and that is another 0, which is equal to, that is 1, 0, and but we have the same plus 1,000, and this here we have v cosine theta, and this second equation, what do we have by the multiplication? We have 45, and then for 3 zeros, right? Here we have the 4 zeros, and this is the 3 zeros. And here we have 0 plus 1, 5. Then the v sine theta. Do you see the two equations? If we use these two equations, again, we divide this to that one. What I'm saying is taking 2 over 1. What do you think is going out to be the division? That is going to be theta, then equals to, we divide, but the sum here is going to give us 2,500. And here the sum is going to be, this is like having 4500 over 20,000. And what do we find? We find this, we find the value, then we can find theta equals to, because when you have this value into your calculator, you find 6 degrees. That is approximately, and we can use this angle to find the speed. So look, so if you want, you can find the speed from this one, from where we have a cosine sine, for example, this one. So like having 45,000 equals to, this is the sum, okay, 2, 5, then cos v sine theta. And then we find v equals to 45. Then the division here we find this is 45 over, this is 45. Let's do it over there. We divide, that is 45. We have a v equals 4500 over 250, then sine 66. And when we substitute this one into your calculator, what do you find? We find 45 over, that is 25, sine 66, and then we find this is 19.7 meter per second. So then, students, because now we have this this question, let's have a homework for you, okay? So the homework that I'm going now to give you is only about it is a similar question. So have this question and then do it as a homework. And thank you very much for having me. And I hope you are going now to do this homework as a way of having more about this lesson, okay? Be good, be blessed. Thank you very much for today's lesson. Bye.